So then they thought we can't approach with this cost to any customer.
Okay.
And then they have said that we'll do something to reduce this cost.
Okay. So you have a technical specification of this transmission?
Not yet. The technical specifications are not free. It is only like it's a 2-speed transmission, and it is switching between first and second speed. That is only the yeah.
Okay.
But more details we don't have. But the target that we have is like I'll just put the bomb.
83%.
So you see this Excel sheet on the screen?
Yeah.
So these are the parts, and if you see, there are so many, like 83 of them.
Okay.
So, and we have weights of these and cost of these. But what is happened? All the other cost that are displayed now, these are high cost contributors. Rest of all are like 2-digit, so not a big deal in that. So these are the costs. Like if you see this housing, the first one itself is costing 1,400 rupees.
Yeah.
Then another housing there is another housing. Like if I say, say this housing you see. So this is one housing, and on other side is another housing.
Okay.
So these two housings, which has internally gears and shafts. Then there is one more casting part over here. If you see this white colored part.
Yeah.
And then this is the electrical parts of it.
Okay.
So
what is this plastic part? Plastic part is basically.
There are actually no plastic parts in this. It is aluminum casting, steel, and gaskets.
This white color is basically metal.
The one in between. Yeah. This is also casting, aluminum die cast.
Okay.
So everything that you see here now, the plastic is only this. Here you see the connector for the electrical.
Yeah.
That is only plastic.
Okay.
Apart from that, there is no other plastic.
So here the steel part is 30, die casting is 9 parts, electrical 4, and hardware 20 standard. Okay. So steel is more actually.
Yeah, steel are more, but they are very, very small in size, and quantity is more.
So cost also lesser?
Cost is also lesser.
Okay, so we
can one minute. In the steel one, see these are the steel items.
Okay, remaining all casting.
Remaining these are casting parts.
Okay, some 6 to 13 is this one. 6 to 13 is okay.
All the below ones are also steel, but they are very, very small, like not big. The 20 mm, 30 mm pins, shafts, like this small.
Okay. Okay, sure. Okay, so now we have selected this one, like
this high cost item.
Yeah. So what we'll do, we will go with. You have the drawings for all each and right?
Yeah, drawings are there for this. But okay, again, then I don't have the assembly and process drawings because they are yet to be made.
Okay, it's not required actually. Now, okay, maybe in future you can collect after you your company.
Yeah. So this is the bill of material. We have the cost.
Material.
Material also we know how this product is, and then I will show.
And you can also get the manufacturing process how they are.
Not today, but we'll get it in next 10-15 days.
Yeah. So that it will be easy for you to.
Yeah. Actually, what we are planning, all these parts now, we are planning to bring from supplier, and then we are planning to assemble it in house.
Okay.
So we will the cost of that will be the assembly process cost. That will be getting added to these parts.
Oh, okay.
So what I was going to show. Yeah, 1 second. See, this is the drawing of that.
Oh, okay. This
Of
is the entire housing.
Yeah, this is one single housing. There is
Okay.
another housing. It is like this from the opposite side.
This is LH or RH?
This now which I'm showing you is the RH, and 1 second. This one is the LH.
Okay. This okay. Different dimensions are there.
Huh.
I need to see the material and all, like what's the overall, like, do you mentioned any material something?
Yeah, material is ADC 12.
Where it is?
1 second.
This
See
is
here.
LH.
See
Okay.
here. See here below.
ADC tool. Okay. So
It's
this is
aluminium.
this is the first drawing, right? This is the first drawing.
First drawing.
Okay. Similarly, you have for all.
Yes, they have for all.
Okay. Okay. Sure. What you have to do now?
Just for our first exercise, I thought let us go with this. Is it okay or what?
Yeah, this is okay. Yeah.
Or if you want, then I have another one. If this is too complicated, then I have this shaft.
Shaft will be still easy also. Yes, shaft will be still easy, I think.
Yeah, because like since I being a student still, so should I go with this or should I go with the casting?
No, we will do it. We will do it. Like anyway, nothing wrong, right or wrong here. So we'll try. So first, what we'll do, we will make this as transmission as a complete one, and then we will prepare a fast diagram for this individual parts also. We'll see.
Okay.
But if you're taking casting, then we have to take complete transmission as our study.
Correct.
So you have to create a fast diagram. Yeah.
That is what my question was, because casting in itself is a very complicated topic.
Yeah. But we have to look at the complete. First, we need to create the functions for each and every individual parts.
Correct. And
then we have to consider the fast diagram with complete transmission itself.
Correct. Because it is a casing and a housing. So
Yeah.
the complete fast diagram for the whole product should be considered actually.
Exactly. Yes.
And this is an individual shaft inside. So
Okay.
on which some gear is sitting. It is meshing with some part inside. So it is like this.
Okay. This is the primary shaft or second? Like you have how many shafts?
1 second. All these are very small. These D shaft and all. These are small, like our even half of our finger.
Okay.
And all then these are all gears below. But still they are in preparation. So gear is again a complicated topic. So then there are 3 shafts, and one which I'm showing you on the screen is the input shaft.
Okay.
You want to see the other shaft also?
Maybe driven shaft we can see. Yeah. Driven shaft. Yeah.
1 second. Yeah, driven shaft. It is a integral shaft and a gear. If you see here, here they have the gear teeth, and here they have some splines.
Okay.
On this shaft.
So you have all the details, technical details.
Yeah.
Number of teeth is 2.25. Okay, 15. This is driven shaft, no?
This is driven one.
Okay.
So,
So now we will go to one by one.
okay. So
We will see. We will open that bill of material.
okay.
So here LHRH housing is there. Then actuation cover is there. And then input shaft. Gasket also you can take, no? Transmission gasket. You don't have the cost?
No, we don't have the cost, and we are not sure about the shape of that gasket.
Okay, see, nowadays they are using the multi-stage gasket, steel one or
Correct.
nowadays even they are using this one also, like Loctite also they are using instead of gasket they are using Loctite.
Okay, that is not yet finalized. So that is why we don't have any details about it.
Okay.
But gears and shafts and these housings are pretty much yeah.
This first driven, second driven, and all this is shaft only, right?
First driven, which number?
9, 10 or gear is it gear or shaft?
Gear.
Gear.
Wherever there is Z, there is gear.
Can you open some gear also? You will see that gear. Number of teeth in the gear. That.
1 second. Let me check. I was able to pull some drawings, but 1 second. No, gear I don't have.
Okay, that is no problem. Maybe just to collect it, nothing else, not proper.
Okay. I'll collect it and keep it.
Yeah. So when is this project going to get launched? Like duration of this project?
It is supposed to get launched in next 6 to 8 months.
Okay.
Because we just have now the concept ready, and based on the concept, we have prepared one prototype of it. But again, not with the production methods. This is with the prototype method.
Okay.
So after making the prototype, seeing how the fitment details are and all, then we had given these drawings to some suppliers, and initially they came up saying that these are the costs, but these costs are too high. Like for a small transmission, these 1400 rupees casting and 900 rupees casting, shaft itself of 434, and all these. It's a small transmission actually. It's a two-wheeler. So, but the cost is too much.
Okay. So now here you are given different weights, right? 2.22. Like here, we can also concentrate on highest weight contributing also. Apart from the cost, what we can do is that for the housing, if the weight is too high,
correct.
Even you can categorize based on the weight also. Because if you try to reduce weight also, no, there is a possibility we can reduce the cost.
Okay.
Even if you do not have the cost details from number 14 to whatever 83 something, even if you do not have the cost details, what you can do?
Their weights are already very less. See now, 0.03, 0.1, 0.02, 0.03. Because these parts are very small parts.
Okay, so friction plate. Okay.
So that is why the above these are what I had chosen, because these are also having weights and these are also having costs.
So and you can also categorize based on the localization, whether you are going to do localization for all the things whatever you mentioned, or whether you are going to do import sometimes you are getting from other other country or India?
No, no, no. These are all are localized.
Yeah.
We are going to build everything localized only.
So this cost is the should cost, right?
This is the should cost.
Okay.
Actually, not even a should cost. The should cost is also to be calculated, because this is going very high. So the now, because of this lockdown, now everyone got this thing. Otherwise, by now we should have calculated the should cost also.
Okay.
So we are facing that problem, because for should cost we need some more detailed drawing, and also we need some management people which will throw light on what should be the target and cost and all of this.
Okay. Sure. Okay.
So then
So this
what
you have cited a supplier also for this, for the all the things whatever you have.
supplier, we have two suppliers which are regularly supplying us. So the ones that are already into our supplier list, the ones who are regularly supplying us the aluminum parts and the steel parts and shafts and all. So like these, they are only considered first.
Okay.
But maybe if they are not giving some more reductions, then maybe the purchase team will think of some other suppliers.
Okay. Okay, sir.
We all got now into problems because of these lockdowns now. That is why half of the work is done now. For a half we are struggling. It is happening like this.
Yes. Yeah.
So how should we start then?
Now maybe we'll prepare Excel sheet. You can type or how? Like I can type. You can type, right?
Yeah, no problem. So then, which product will take for this thing? Shaft or what?
No, first I will also share the screen. Like you do like this.
Okay. 1 second. I'll stop sharing now.
So here what you have to do now, like you can create one more Excel sheet like this.
Okay.
Put the same thing like what number 1 to 9 or something like that. Serial number and the name. We can put the name here.
Okay.
And then the description, basically the part number if you have. Otherwise, part number you can put like this.
Okay.
And then part description.
So what will come in description?
This is not the name now. This is a part number is there. If you have part number, you put it. Otherwise,
okay. Yes. Part number we have. Okay. No problem.
Then you put the weight. I think weight is not an issue, or you can put the cost directly.
Okay.
And then you put the cost.
Okay.
So what you can do, 1 to 9 you put, and you put the total cost here.
Okay.
You put total here. You calculate what is the overall weight, total weight, and the total cost here.
Okay.
So then what you can do is that you can put the cumulative cost percentage. Okay. What you can do now, like you will get some value here, right? So this divided by the total. This divided by total into 100.
Okay.
So means that you have to find out for all the individually.
Okay.
And then even if possible, you can add the cumulative weight percentage also. It is not required, but again we will go something slightly advanced level. we'll put cumulative weight percentage here.
Okay.
And then so for this weight, decide the total weight. We'll give this cumulative weight percentage.
Okay.
So what we can do, we will take the transmission as the complete product. In that, we will take only this nine parts alone.
Okay.
Okay. We will assume that this is the 100% cost. No need of taking other thing. So
Okay.
only we will take this alone.
Okay.
Okay.
Yeah.
And then what we have to do is that then in next sheet we can create the function for the individual 1 to 9. We will create individual. We will create the verb and noun combination.
FC.
And the resource also, now also you can allocate the resource here. Resource also we can allocate in the next column. So here what you can do is that name, description, no, only name, resource percentage. So here next one what you have to do is that the name, then the resource percentage.
What will come in resource percentage?
Resource is nothing but 100%. So here for this 100% is there. So this divided by this will be the percentage here, right?
Correct.
Okay. For this particular percentage value, you need to put this percentage here, resource percentage or cost percentage.
Okay. Okay. Okay.
But here it's like not only resource means not only the cost but also additional thing. But you can put as a resource only. Still, it is micro level. Like we can do it like in general, because suppose if you are hiring any manpower for this project, then even apart from this cost, you also need to spend some money for that additional manpower, right?
Okay.
And also the additional thing also will be there. But what you can do, we can take the same cost value as a resource also. But normally resource means it indicates not only cost but also the material or the other resources also will be a part of the percentage.
Okay, what I'll do, first I will create the sheet 1.
Yeah.
And then I'll move to sheet 2, because then
yeah, in sheet 2, then what you can do, just I'll tell you what the structure will be: verb and noun.
Okay.
And then the category, is it a basic function or standard function? There's a category.
Okay.
We will do it for 1 by 1. 9 1 we will do it. And then so here for 1 for number 1, assume that we have some 4 5 name this one. Okay. So what you have to do is that this is the overall resource will be there. Overall resource percentage will be there. So against that, for the individual verb and noun, what is it for the individual function? We have to give the resource like here. We need to create one more thing.
Like the one we did for that lab.
Yeah, for this. So here again you have to put percentage resource. Here you have to put the overall resource percentage. This is the overall resource percentage. You are telling some 2 point some value you are telling 400 rupees something you are telling.
Right.
Suppose 400 is there. So for the individual function, so maybe 100 rupees, maybe 50 rupees, like that you have to.
Okay, for that function. Okay.
Yeah.
Okay.
Okay, and so maybe like maybe 60, 40, then 200, then 20, like that. It may be like this. Okay.
Okay.
So you have to create like this. Then we have to find out the verb now. And as for the 9 parts individually you have to find. Then we have to go for a fast diagram.
Okay.
Then accordingly, even without fast diagram also we can like straight away also we can look into it. Like what with this verb and noun combination, we can try to understand this is contributing more cost.
But we'll do one fast diagram also. That will then help me also.
Yeah, fast diagram you have to do. Yeah. While doing the fast diagram, you have to see transmission as a whole, and also these 9 parts also you have to consider.
Okay. So shall I prepare this?
Yeah, first we will go step by step. Yeah.
Okay. So should I prepare this at my end here?
Yeah. Otherwise, I can also type what you feel. If you feel.
Yeah, if you feel that typing is too much, then tell me then.
Okay. So I can. Okay. You tell the value. I will type, right, or how?
Okay. Because okay, name 1 second. One second.
Yeah.
So the first 1, 2, 3, 4, 5, 6. We'll take for 6 because we have drawings for these 6 parts.
First 6.
You told 9 parts, na? But we have drawings for these 6 parts.
It doesn't matter. You can take first 9 also. Even gasket also you can take, no problem. Because all these are general thing. You can take, no problem.
Okay. So first, or shall I do it, because it will be
Yeah,
fast.
You can do it.
Okay.
You share the screen. I will stop sharing.
I'll share you the screen. Yeah.
It will be easy also for you. Because
yeah.
You can present also next conference. You can present or you can take it.
Okay. So what I'll do, I'll add in here only.
Yeah.
So it will be easier. So first was number, then was name, then was part number, then was description, then was weight, cost, cumulative cost percentage,
No, up to 13, not 13 parts, no. Because you have 13 parts, right? Totally.
Yeah.
Cost. You go to this new BOM, how many?
Which one?
New BOM you go to your bill of
okay.
Up to 14, 13, 14. Yeah, up to 13 we can do it. Okay. Even motor actuation shaft, even though we do not have the money, what you can do, we will be there. Okay, we will do that one only. Up to 13 we can do.
Or we'll take
No, you put it in highlight, like go down also. We can because the pressure plate and all is quite interesting. Maybe even though we do not have the cost, maybe we can take that one also. Pressure plate, and then clutch housing, because clutch housing and the LH RH housing is almost the same functioning. Because maybe
but the clutch and all is will be bought out item directly.
Okay.
Because clutch belongs to that OEM, no? So we will be using their clutch.
Okay. Like so this. Only for the top 13 is highest cost contributing, no? And also this is like a localization and this one. Okay.
Yes.
It is the proprietary, no? It is like all this will be done from your side.
Yes.
Remaining all their thing or bought out?
No, all are bought out only. But some are bought out from the customer directly, because customer is going to provide us the clutch, and then we are going to use that clutch, and then the other ones are the small bought out items from the suppliers.
And the complete assembly will happen in Pune.
Complete assembly will happen in Pune.
Okay.
So what I'll do, I'll take the names.
So it's basically gears, shaft, and housing. Only three, basically. These three aspects we have to look.
Okay. Then I will take these 14, okay?
13, yeah, 14, yeah. Because, see, I can give one example. Go to the same thing, same slide only you go. The slide, the number, first, second, first driven gear, second driven gear, difference gear, and gear function will be same, almost same.
Correct.
For all the things. So instead of all this, like we can also put as a complete, instead of first, second difference gear, what we can do, we can also put general term as gear, and we can add all the three values, 220, 200 plus 1. We can add that and we can put it separately also. You can do like that also. Instead of even you can come down and you can find some other gears or shaft like that. No, you can club like that also. Reverse gear fork is there. If it is reverse gear alone, no, we can put that also in the gear category. Otherwise, you give me control. You give me control. Control. I will take control. Hello?
How do I do that?
Control is possible. Control. 1 second. Request remote control. Okay. Yeah. Now I'm requesting the control. 1 second.
Okay.
You got it right. So here, it is the driven shaft.
Right.
Sorry, gear. First drive gear, second drive gear,
right.
And then
first driven, second driven.
This is a gear only, right?
That are also gear.
Gear and difference gear is also gear.
Correct.
And then when you come down, if you have some other gears also, what?
The worm below that only you have the worm gear and the worm gear.
Okay. So what we have to do now? We can also club the thing, like when you're going for this fast diagram. So what you have to do, instead of putting first, second, something like that, you can generally name it as a gear.
Okay.
And part number you need to put, and then description also.
Wait, then should I add weight of all and put?
Yeah, you have to put the weight that you have to drag and put the overall weight and overall cost.
Okay.
Then because the function, if the function is almost same.
For gear, all the functions will be same only.
Yeah. Then this will also narrow down our work actually.
Okay.
Instead of putting 13 individually, no, we can also club like that. Okay. And even housing also like this only. LH, RH will be same. Okay. And you can also find some other housing, even the clutch housing.
Yeah, okay.
This also is almost, it is nothing but protect actually. It is an outer case.
Right.
And if you have some other housing, even housing, other thing also can be one thing. So what I feel, housing, gear, shaft, three separately we can do it. Okay. Then we can add some more, additionally we can add, because it's almost same only. We will add additional thing. What you feel, which one we can take? Gear, shaft, and this one. Then if you have any differential, case differential is done. This is also housing kind of thing, right?
That is also housing.
Yeah, we will take all these things later. Housing category. First we will take as housing category, then gear category, shaft category. Okay. Then if we have anything apart from that, maybe the clutch itself we can take, or some friction. Clutch also we can take separately, because clutch is having pressure plate, friction plate, spring this one. Maybe we can take clutch also as a single one. What do you feel? Clutch you can take it?
Or we'll take only housing, gear, and shaft.
Yeah.
Because other parts now we don't know the weight of that, the cost of that.
Okay.
So I think whatever we know we will take. So it will be easy for us also to get the calculated cost and all.
Yeah, sure. Yeah.
Okay.
So what I feel in here, gears, shaft, and then housing only three. Okay. Yeah. If clutch is also there, then we can take, otherwise we no need
No,
to
but
take.
actually, now clutch is not our part. Clutch is the customer part. Yeah. So
Okay.
clutch is whole assembly. Clutch is given by him only.
Okay.
So that is why we are not targeting that clutch.
Okay.
If it would have been our clutch, na, then we would have
Mhm.
targeted that also.
Yeah.
Okay. So can you give me control again?
Yeah, I given you.
Okay. So what I'll do? Here I'll do cumulative cost, cumulative. Okay. Here I'll put 1,000 and years share. Then part number one description. Description will also be same.
Yeah.
Okay. Wait for 1,000. So it comes 4.40. So 4.4 gears. 1, 2, 3, 4, 5, 6, 7, 2.88. And share is so share is 1, 2, 3, 4. Cost of housing. 1, 2, 3. So it was 2, 4, 1, 3. Then here is 1, 2, 3, 4, 5, 6, 7. So this one is so 1, 2, 3, 4, 7. From 7, 1, 4. 7, 1, 4. And the shaft is 1, 2, 7, 7. Okay. So where we want to put total. This is this is equal to cost. This divided by this. Shall I round it up? Hello, Arjun.
Yeah.
Shall I round it up?
How much is coming? Round it. Yeah. Okay. Yeah.
So it comes like this.
Yeah. Housing is more actually.
Yeah. So if I okay.
So what you can do, even I feel uh, even you can put this is the known value. Known value, let it be like this.
Okay.
Suppose from go to the new bill of material, even you can take some two additional three parts where you do not know the cost value. Maybe that, that also you can look into it.
Okay. So
Some only three parts, like maybe the one can be related to clutch, and the other two you can decide which you feel is most important. Even differential is also very important, no?
yeah. Or shall we consider these electrical parts?
Electrical will be good, yeah.
You know.
Ah,
So these are four parts. So shall we take all four then?
yeah. Then in this case, you can put sensors, motor, switch like that.
Okay.
Separately, you can take. Okay, but maybe what we'll do? Maybe electrical hardware. This is a different commodity, no? Electrical will be a different commodity.
Okay.
It is
Pardon?
like apart from housing, gears and shaft, electrical hardware is individual name. It is a separate thing. And
So what we should take then?
we can take, but the thing is that we do not know the cost value, know. So,
We
but
don't know the cost.
okay, okay, better we will take only these three only.
Yeah, that is better.
Yeah, too much is also not good.
Yeah, yeah. Too much of
Anything.
unknown values will also create a problem.
Yeah.
Okay,
Whatever
so
we have, this value we can try to do something.
yeah, and then next sheet or I'll create on next sheet.
Okay.
Uh,
Yeah.
name, then overall
Resource percentage.
resource percentage. Then work noun category and percentage resources. So again, in this sheet, again I will put these three names, right?
Yes. Yeah.
And here I will put some more rows so that for these.
Yeah. Verb and noun. Yeah.
Yeah. So, so this will be like, for example, housing, gears, Then correct?
Yes, you are right. Yeah.
Or we'll make this a bit thicker so that we understand separately. Okay.
Yeah.
Okay. So I'll go back here. Okay. So how should I start then?
Yeah, we'll start to one by one. First, we'll start with housing.
Okay. So what we'll put in overall resource?
You put you club immersion the center completely. You
Okay.
put the same value in sheet 1.
So I merge this and I what I
Yeah.
should put?
Yeah. You put the value what you got in sheet 1. Overall cost. Yeah, sheet 1. Overall cost you put. Overall cost is
This one.
no 3213. And then bracket you put 57%.
Okay.
So and then what you have to do here, no, like in percentage resource, you have to give percentage and also cost. Both will be good, still good.
Okay, I'll go one by one. Okay. So this is gears. Gears is 1714 and 30. 1714. I'll go 727 and 30. 727. So much. Okay. So okay now. Yeah. Now what?
So here, yeah, then what you can do, yeah, this is over. We can directly go with the verb noun.
Okay.
Okay, so
function
housing.
one.
Housing, it's like basically housing, you should meet the specification.
Housing one will be meet specs. Yeah.
Yeah.
Then
Meet specification, and then it should also
sustain.
withstand the vibration, like because vibration is very important.
Withstand. Withstand what you said? Weight.
Vibration.
Vibration. Okay. Vibration. Enclose internal components. How we will say that? Or protect. Protect, right?
Yeah, protect component or maintain integrity. Maintain integrity is also good. Maintain integrity or maintain position.
Yeah.
Maintain integrity. Maintain integrity is good.
Integrity. Then protect components.
Then you can also look in other aspects also, like housing is having different features. even if you want to provide any, there should not be any corrosion also. So resist corrosion. Should resist corrosion.
Prevent corrosion.
Resist.
Resist. Okay.
Yeah. Resist
corrosion. Maintain strength or durability. Or
yeah, maintain strength is good. Yeah, maintain strength. Maintain and then ensure reliability. Ensure reliability, ensure durability.
Reliability.
And even safety also very important. Maintain safety.
Yeah. Sure. Safety. Then testing.
Ensure safety. Protect product. Like it should also protect component. Maintain it. Protect component is okay. Protect product is also protect components okay. Then apart from
testing. One second. I will open the drawing so it helps us.
enhance appearance because the appearance is also very important. Again, it should also connect components. Enhance appearance, connect components already written. Connect components already written. Maybe protect products, protect connect. Okay, connect components is not written. Protect okay. Then maintain strength is written.
Maintain.
Strength is written, right?
Spelling.
Maintain strength. Strength is written.
Strength is there up here.
Okay, then we can write.
One is the strength we gave, vibration we gave, hold or protect component we gave, locate component we gave.
Meet standards also apart from specification. If you have any standards.
Yeah.
Meet standard. Specification is with respect to dimensions.
Yeah.
Standard is something like
and then we can say meet life.
Life.
Huh?
That's why we put ensure durability, reliability. No.
Okay. Yeah.
So you can put identify brand, which company they are giving some logo also for that.
Okay.
Identification. So there is no temperature, no, only vibration.
But all that will come in spec, no? The standard or the spec.
Specification is nothing but dimensions. Standard is nothing but like
there are material standards. There are material standards also. So ADC 12 has melting point and all inside.
Yeah.
So what was that? Before that you said something.
Meet standard you can put.
It's already written.
Meet specification we have written. Specification is with the
Yeah.
One second. Is it written?
Yeah.
Meet standards. Okay.
Next one. And this is down.
Yeah. Then now appearance is also. Then what about we are not going for any coating, right?
No.
Any heat treatment? Okay.
No. One second. I'll just open this one.
You open the drawing so that you try to find something.
Yeah. Yeah. Logo you told, na? Logo.
Logo that is there. Yeah, that we need to
display
identify
logo.
brand. Identify brand.
Okay. Identify brand. Then
Safety you written, improve safety or ensure safety.
safety we have written. Ensure safety.
Okay.
Safety.
And what are the other functions normally? The housing you should protect.
Yeah, it should protect. It should hold, or is this thing, the shafts and all internal.
Okay, and again you have the gasket in between, right? So it is also need to ensure leakage, no leakage. So prevent leakage. Basically,
That is function of gasket, na?
gasket, but again, since we are not considering that, even this is also should be there. But yeah, it should come. It should be
Avoid leakage.
no, prevent leakage. But normally, leakage should not be there because we are also doing some leak test. No, leak test we are doing, right?
Correct.
So for that, we need to ensure that the leakage should not be there. So even though the gasket is similar thing, but here we are not going to spend money, I think, because this is will be a part of
the whole product, huh?
Yeah. So maybe, but that is a function we have to.
Yeah.
And again, it should resist the environment also. Resist environment you have written apart from corrosion. Resist environment.
Resist environment. Okay.
And again, it is also having some bolts. This fasteners also will be there, which will help to hold the thing. So the function of the fasteners are this one to enable the torque, but the housing is connect component. No, but the connect component is good actually.
We have written there, na? Protect components, then connect components we have written.
And what about warranty? Whether your supplier is giving the warranty for this?
So that is life.
Overall, but even
warranty against any leakage, breakage, like defective part. But I think, do we write warranty? Do we write such
warranty? But for a complete part, we need to look. It's a one-time function. One time you have to.
Correct.
But what about the supplier? Whether they will give like OEM, they will give. Now you are the OEM because you are completely manufacturing the transmission, assembling the transmission. So
right.
You have to give the warranty to your customer. But
Correct.
your supplier, whether your supplier is giving you the warranty for transmission or gears, or if in case any gears failed, and complete transmission itself will fail. Or if any shafts,
supplier will give based on this thing, defect, because when we give them drawings, we give them standards, and we material standard, dimensional standard, then chemical composition, all these we give, so that if they ensure all that, then there is no defect. Even the quality people, they set up norms against them. How much should be what should be if it is a casting, what should be the size of the pores, how many pores should be there, all these details are already there in the standards. So apart from that, then there is no this thing, because if they don't meet standard, then only they are going to produce defective parts. So apart from defects, we don't take anything from supplier. And the warranty is what we give to our customer, but not the supplier would not give to us. If the parts are defective, then it will be debited to the supplier.
Okay. Okay. What about the friction? Friction will not be there, no, because it is outside
No,
compound.
friction, because it has bearings inside.
Bearings
so, wherever you see that holes for the shafts and all, so there are bearings. So there won't be friction.
Okay. Friction is not there, and now what about the force? Is there inside any force is getting transferred, or any applied any force or pressure is getting
that comes in strength, now maintain strength, ensure durability. All that comes in force, because whatever force comes from inside, that should be sustainable by the housing. So that is coming in strength and durability.
Right, but
because you do the FE and all for strength and durability, right?
But normally the shaft and the gears which is there inside the housing, so they transmit torque, they generate some force.
So that will be then sustained force will be the housing, because whatever force comes, they have to sustain that.
Okay, which means withstand force.
Withstand force. But we have written withstand vibration now.
Okay, no, vibration is like because of vibration, because of force, the vibration is getting.
Vibration will come, yeah. So then shall I add withstand force?
No, how like withstand force, instead of withstand force, it is generating force, or it is.
No, it absorbs.
It absorbs.
Because the casing, they generally absorb the force.
Withstand load actually. Instead of force, we can put load. Force is transmitted in terms of load, right?
Yeah.
It's support weight. Support weight is also good. What do you feel? Support weight?
Load and support weight, right?
Any load is a form of weight. So any one we can put. Which is the
then
best one?
I'll write withstand load, because there are different kinds of loads then.
Yeah. Then that is withstand load is good.
So I think, shall we move to the gears then?
Once I'll just check it. Almost covered everything. Okay, withstand load for. Okay, then.
You're able to see my screen, right? You're able to see my screen, no?
Yeah. Normally, okay, this is anything missed out, something.
Prevent outside thing inside, or prevent like it should not allow any entry inside, right? Any mud or dust or.
That is resist environment is there.
Okay, environment. Okay.
Even prevent leakage also is there, and outside inside. Transmission, you're using the fluid transmission fluid. And pressure. Any pressure is there? Any withstand pressure? Not it should also. Withstand load is okay. What about the pressure? Because the
pressure will be due to load only, no?
Okay.
Because load means what? Weight. So whatever self weight or the weight of internal parts, that is one weight. The other one is the load. That the pressure is because of the load and area, the pressure will be generated.
Okay. So now what we can do, we can categorize this first. We will complete one by one.
Okay.
We will find out what is the basic function of a housing. So housing is the basic function is to maintain
components.
protect components will be good, or connect components. Basically, it's a housing. It protects the inside components.
Right.
So basic function can be protect component. So you can put in category. You can put B. It's a basic component.
Okay.
And the remaining all will be a secondary function. You can put yes. And why to protect component to enhance drivability, right? To enhance performance. That can be the higher order function.
Why to protect?
Like we follow Hawaii diagram. So if for this housing, if the basic
why to protect component to
enhance to transmit torque, means the overall function is to transmit torque,
right,
or to transmit that is for transmitting power or developing power to the engine, and finally the vehicle performance or the vehicle movement. So you can put improved performance can be, you can put that is anyway that is out of scope.
That is out of scope. Yeah.
So just you can put improved performance, maybe you can put, and you can put that improved performance as higher order function. Even for gears also, that can be one of the higher order function. Develop power, yeah, improve performance, or then what like develop power. Even the power is also transmit torque. Why to transmit? The overall function, basic function of a transmission is to transmit torque.
Right. Right.
So why to transmit torque? To develop power. So even develop power can be the higher order function.
Correct. Correct.
You can write develop power also, maybe. But anyway, we are going to, anyway, this is not in our scope, but at least we can put.
Yeah. Develop power, right?
Yeah.
No, transmit power.
Yeah, transmit power. Yeah. Oh, yeah, but anyway, finally it is developing power, transmitting. Yeah.
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 So, shall we go to gears?
No, and again, what we have to do, no, we will complete this one only.
Okay.
So in percentage resource, what we have to do, we will put in terms of 100%. Like for this 100%, we need to allocate for each and everything. So
should I make it one cell?
No. Better you put this individually also is good actually, so that you will understand which one is contributing to the highest percentage cost.
Okay. So then the basic will have highest weightage, right?
Yeah, maybe out of this 57%, you can allocate accordingly. So 50% goes to this, right, or how you feel?
Yeah. So
maybe you can put 23%, 27, yeah.
%.
Yeah. Remaining 30% you have to allocate accordingly.
Yeah.
So it is not required sometimes. If for meeting specifications, some few percentage, meeting standards, you need to spend some money, and for resisting, for withstanding vibration, you have to definitely spend some 5% money.
Right.
5% means here you can put maybe some. You can put 8%. You can put 8, 9. 9 you put.
9.
Yeah.
Again, meet specification is important, so 5% for that.
Right. And meet standard also, you need to spend some money, 5.
Safety is important.
Yeah, you put some 3. And if you are maintaining the specification standards, then if you are protecting the components, then the safety will not be an issue. Right now?
Pardon?
If you are maintaining the specification, meeting the standards, and if you are protecting the components, then obviously the safety will not be an issue.
So should we give to safety or not?
Safety we need to give actually, but very like maybe some 3.
Okay.
Again, for this only you need to involve the team actually.
Okay. So here we'll give this thing.
Yeah. Again, for connecting components and Anyway, it is not because it is a function for which we are not spending additional cost or additional resource.
Right.
Even for identifying brand, maybe very few money, like some
Yeah.
one percentage, something like that.
Preventing
Preventing
is also one.
one and withstand load. Anyway, it should maybe for that also we can use some 3.
Or 2. Yeah.
Yeah, 2 and resist environment also one percentage.
Yeah. Standard is also one.
Yeah, standard you need to spend some money also, not like
So
you
3.
have a lot of yeah, and okay.
Enhancement is one. Ensure durability is more because
Yeah, durability gives some durability, reliability is very important.
yeah,
3. Strength
strength,
is also very important. 3.
corrosion is also correct.
Yeah, maybe yeah, that's also
Integrity is also there. So let
3.
me
You can
see how much this happens. 68.
60,
68. 68.
68.
So I'll need to reduce somewhere.
Yeah, you can
6. Then spec is 2. Then this I make 22. 59. So 2 I need to reduce.
1 you can reduce to either maintain. Okay, resist corrosion you can put 2. Resist corrosion you can put 2. Resist environment you can put 2.
Environment is 1. And
Or we can put some additional connect components. Okay, maintain integrity is otherwise you can put 23 to put the components also.
integrity 2.
Integrity is 3. Now how much is coming?
58.
58, no?
Ah.
No, 58. Then it's correct only. 57 is there.
So should
Maybe
I put
vibration you can reduce 1.
pardon?
Vibration you can reduce 1.
Yeah.
Okay. Even you can reduce vibration 4 and then meet specification and standard 3. It can be meet specification. Yeah, meet specification you can put 3.
Okay.
I think this is quite reasonable.
Yeah.
Correct, no?
Correct.
Okay. Sometimes what happened, durability and reliability is the same meaning. Sometimes what we have to do, we have to adjust.
Yeah. Durability is like lifetime. It should that is the one-time function. It should be sustained whole life.
Sometimes maybe the put together also they will give, and again you need to look which one you need to look. And again for this only the individual casting team will be a part of this.
Yeah.
And
So
again,
for time being, let's keep it this much.
yeah, sure, yeah.
Okay.
Yeah.
Then
So here now we notice protected components is more here. So then we need to look for ideas. Like basically, I'm telling even without fast diagram also we can look, like you can see, no, like how to protect like you can look for some alternative ways to protect the components, the housing, the materials. If it is aluminum, then we can see it can be whether it can be done in an alternate material or different material composition. We can look into it. Like basically, we need to target the highest percentage contributing factor.
okay.
Basically, in that way, also it's good actually. Yeah. Next, we will go with the gas.
So this is the highest contributing factor.
Highest percentage. Yeah. And then next one is 4. 4 also you can highlight 4. And then 3. All 3 you can put in third. Yeah. 3, and then I put only 3 alone, and then 3.
Yeah.
Yeah. So one more 3 is missing. Maintain integrity.
Okay.
So now when I'm adding 7, 10, 32, 35, 38, 41, 44, 47. So 47 divided by 57. How much it is coming? 47 divided by 57.
47 divided. divided by 7.
Okay. So see now, now 80% of the cost we are focusing. Okay, so by identifying the top 3 functions alone. So first function is protect components.
Right.
Second function is withstand vibration. Third one all together. So instead of all together, you can also see like 26. Yeah, even you can also look into these are top three rankings actually basically. Top 3 rankings. So top 3 rankings contributing to 80% of our cost. So you can also create the Pareto diagram. Like you can also create a chart also, like you have seen in the book, no? They created the Pareto drawing. So even you can do that. Even we can create some graphs respect to cost also. So you can highlight this to your top management. So still we can look for more ideas. Something can come out of it.
Okay, so shall I select only top 3 then?
Yes, top 3. Yeah.
Because now this strength, reliability, durability, all these are interrelated.
Yeah,
so,
and then and even maintain mid standard also will be same.
Correct.
And even the mid specification is also same. So all maintain intelligence is also same. So all put together, what we can do, we can put as a maintain strength.
Maintain strength, yeah.
Yeah, if you maintain strength, then all the things will be met, right?
Correct.
You can take in that way.
Okay. So then here I'll 1 second.
Even this is also good. 26, 29. 29 divided by 57. Even they're also close to, yeah, even that is also good, I think. 29, 26, 29. Yeah, 29 divided by 57. It's still 60% is also good. 51%. Still, it's good only. Still, it's good actually.
Yeah. Top 3 contributors, right?
Yeah.
Top 3 contributors. Okay. So it means that 51%, these 3 contribute to 51%, right?
No, this 51% is out of this 57. Like not so like for this 57, 29%. Which means, see, sometimes you may not find your battery is low.
Yeah. I switched on. Yeah.
See, what you have to do, you have to look for if you're finding some time, then you can individually get ideas for the individual function. Otherwise, you can also concentrate only on the highest cost contributing factor.
Okay.
So that your focus also will be quite like more focus you have towards.
So by this we are identifying which to brainstorm, right?
Exactly.
Okay.
But normally we can also go to the fast diagram. This will be much more better. Okay. So in fast diagram, what we will do now? We will try to eliminate the unnecessary function.
Correct.
Okay. Still we can. Still that is still much more effective.
Okay. So as of now, till here we are so much like this. I'll just
yeah.
So in fast diagrams again we will refine them more. Yeah.
Exactly. Yeah.
Okay. So then shall we move to gears?
Yeah.
So gears again mid specs will come.
Yeah. The basic function of the gear is to transmit motion, as well as it will also transmit power from one shaft to another shaft. Basically, it's to transmit power. Basic function, we can start with the basic function, is to transmit power.
Okay. Then provide rotation.
Generate rotation, because it rotates. Generate rotary motion is that it transmit rotation. It transmit power or it transmit torque or transmit motion or generate motion. Generate motion is good.
Okay. Provide is not a good word, no?
But transmit will be good actually. Transmit or generate will be good.
Okay. Because I think I remember they mentioned this in the last conference also. Don't use provide and all such words.
Yes, yes.
Okay. So generate motion. Then gears is to again strength, reliability, durability. All these will be there.
Yeah.
Because gears teeth should ensure strength and all.
Yes.
So I'll copy these.
Transmit power, generate.
Yeah.
Generate rotation, no? Generate rotation. It rotates, right? Gear rotates. So instead of motion, generate rotation or rotation. Yeah.
Then these
But gears does not transmit torque, right?
yeah, they transmit torque, no?
Transmit torque.
Yeah.
Transmit power. Yes, transmit.
Power,
Okay.
torque, all these are like same this thing like
Yeah. So how to transmit torque? But transmit power by transmitting torque. So you can put transmit torque also as secondary function.
Transmit torque also.
Yeah. And how to transmit torque by generating rotation? How to generate rotation by applying force? Maybe yeah. Apply force, receive force also you can put. Apply force, receive force.
Apply force. Correct. It will receive also.
Yeah.
Receive force. Then withstand load also.
Yes, it should withstand load, and basically strength is also very important because the teeth, no, if it is getting failed,
Even
here the strength is also very important.
Yeah. So I've written here. Ensure. Okay. I forgot that. Maintain strength. Okay. With meet specs is also important. Because gear they have the meet standards are also important. Even this resist environment, corrosion, all these are important. Then leakage is not a function. Then is not a function. Connect components would also be right because it will connect itself with the
go up. Now see go up actually. Now see if we have missed something.
Housing.
Yeah, housing go up. So here meet specific vibration we have mentioned, and then components will be there.
Receive force will be in housing also, no?
Oh yes, apply for receive force, apply force will be there also.
Here we have said loads withstand, but receive and then withstand, right?
Yeah.
Receive load or receive force. Yeah. Then here I will give 2. Here I will give 1. Or here I will give. Okay. Then standard load gears. Give force, receive force.
And pressure also gets it will get some pressure also, right? Generate pressure.
But that will be only because pressure pressure more than pressure because it is a line contact now. So pressure will not come actually, no? Because it is not having any area, right? The gears are in contact with each other, they make line contact.
It should also withstand temperature. Friction.
Yes. Yeah, friction and temperature both.
Increase temperature rather than temperature, friction is more, I think. Yeah, both withstand temperature and withstand resist corrosion. Sorry, resist friction.
Resist friction and the important one, yeah, temperature. Withstand temperature. Or withstand heat or what temperature?
Heat, yeah, it's a temperature both are high.
Yeah.
Normally temperature in terms of degrees Celsius. Heat, yeah.
Okay. Noise.
Yes. It also create noise.
One of the important.
Yeah.
Withstand, receive, ensure. Avoid noise. Avoid.
No. Like minimize noise. Minimize maximize we should avoid. Withstand noise. Yeah. No, we should avoid that. Minimize maximize. We should not put that minimize.
Avoid.
Avoid is a verb. Noise or minimize. No, withstand noise.
No, it should not produce noise. No.
Not produce in the sense.
It should.
Avoid is a verb.
What is the opposite of produce?
Avoid is a verb something. Verb or not verb. Use with object.
Reduce noise.
Prevent noise. You put prevent noise.
Okay, correct. Prevent noise. So the friction, noise, heat, corrosion, environment, source, flow, transmit. Gear. Corrosion also we have written. Ensure hardenability. No, but that is the property of a material, not of.
Yeah, but even that is also important for hardness because it's in the strength you are having this hardness.
So withstand hardness or with.
Withstand hardness is. That will be the project objective. You can say it in project objective. Withstand hardness, maintain strength.
Yeah, that will all.
Even for housing also you can have that hardness.
No, but all that are part of strength only, na?
Yeah.
So it is like everything comes into strength only. Na?
No, but again, withstand hardness would be good actually. Still,
but hardness here is like the gear should maintain that hardness till the end of its life. And aluminium, how it will be hardness? Aluminium will be stiffness.
Yeah, maintain stiffness.
Aluminium will be stiffness.
Yeah.
Stiffness or toughness, whatever you want.
Yeah.
So safety I'll give 2 and then stiffness also I'll give 2. 58. Okay. So when we say we maintain stiffness, how will we maintain stiffness? By uh, maintaining strength, or then by maintaining stiffness, what we say? Maintain stiffness by maintaining thickness.
Stiffness is nothing but a load by displacement. Like that is like withstanding load, then we can maintain the stiffness.
Correct. Nothing related to thickness.
Even that will be there. It is nothing. Basically, stiffness is also mostly for spring only. Is basically the object resists to deformation.
Okay. So then toughness, should I write toughness or what?
That much individually we don't need to mention too much like that.
Okay, then I'll remove that. Then.
Yeah, even stiffness also not good, but mostly for spring we go for this stiffness.
Okay.
Basically load by area deflection. If even that is even deformation can happen in housing also, because the load and even vibration and even possibility is there, but the stiffness is mostly applicable for this spring.
Yeah. Okay.
Toughness is nothing but the ability of the material to absorb energy.
Yeah,
Even
it is a material property.
yeah. It should deform without fracturing. Even you can put that. Even the toughness is very important with respect to housing.
Toughness?
So toughness is important, but even the maintenance. If you are maintaining strength, then it is nothing but maintaining the toughness.
Yeah, yeah. So all that comes into strength only.
Yeah.
So I think sufficient.
Yeah.
So transmit power is the basic. Transmit torque is again a subset of power.
Exactly.
So it will be secondary. Then apply force and all these are secondary only, right?
Yeah.
Okay. So now we give the percent resource.
Yeah. And even we can complete the shaft also. Then we can go for it.
Okay.
The shaft also is same only.
Shaft also, since it's a steel part and it is also integral with the gear. So most of
again it also the basic function is to produce power, because it also produces power by absorbing power, or here also it rotates. It's a rotating machine basically, a rotating element, generate rotation.
Yeah.
It transmits power. Actually, here it also transmits power. And
then again,
it also produce power. It also like produce power. Like same whatever you have mentioned in
all these will come same only.
Yeah, but the basic function is to transmit
power.
Sorry, transmit power. Yes.
Yeah.
There is no change again, but here the noise. Yeah, noise is very important here.
No, in shaft it will not have noise.
Vibration will be there. Withstand vibration.
Vibration will be there.
And withstand hardness is not required. No? Hardness and prevent noise we can eliminate.
Hardness is required because it should not be bending.
Okay. Yes.
Fatigue strength and bending strength, all these. Yeah. So shaft. Resist bending. Because if it doesn't resist bending, that means the gear and all, it will be transmitting load. That is also failure mode actually. Is it okay? Or?
Is it the primary shaft something?
Pardon?
Is it a primary shaft?
Primary?
The shaft is a primary shaft something.
Yeah, primary also.
It is used to connect other components also.
Yeah. It has gears on it. Then it connects the bearings also to the housing. Then it also takes force. It transmits load force. It transmits torque. It sustains vibration. Then corrosion, definitely it has to meet. Friction is not a part of this thing. Friction will not come in here because it is already in the bearing, right?
Yeah.
So friction will not play a part here.
Yeah, you
Friction,
can remove.
friction is
Yeah.
where it is. So I'll remove this. But I think we should keep bending.
Bending is a material like that shaft. It should bend.
Because if it is okay, I think bending will also come in strength only then.
Yeah.
Okay. Then what else in shaft? Uh, what we say? Ensure machinability, or that is again material property.
Yeah, material properties.
Mm, shaft. I'll just open the drawing of shaft 1 second.
Maybe you can see the drawing also.
Yeah, that is easy.
Yes.
Yeah.
Harness the human then depth of the dimension part should be free from burr. Then number of teeth is under.
Yeah, these are all machining parameters. So because it has spline, so it will be used to transmit tower power, all that.
Yeah.
Then, strength and all is okay. And all that that are these are part of machining only, the roundness or run out and all this. So that is again machinability. I think sufficient.
Yeah.
So, yeah. Okay.
Yeah. So now we can go for allocation of the resource.
Yeah. Now out of 30, so 30 is our total overall resource. So
Yeah,
from
otherwise, you can also do like this. Like no need to consider 30. You can put this as like you can consider this 30 as 100%. So from this you allocate 100%. Like for transmitting power, how much is the percentage out of 100? That percentage into 30. Like you can put in that way, so that it will be easy also for you.
one second, 1 second.
Or you can take the cost also. Like in whatever way you want, you can.
Cost only, we have taken basically cost only.
And cost is also okay. Instead of resource percentage, even cost is also good. But, basically, resource percentage will be still much more better.
Okay, then we'll go with the resource percentage. But for resource percentage, we have taken the cost only as the criteria.
Yeah, cost, yes, you're right. Cost basically. Yeah.
So what does this mean for third? Consider 30% as 100%, right?
Yeah.
And then allocate. Okay. So then basic, like to transmit power is the main function.
Maybe 30 percentage.
Yeah.
You put 30 percentage.
Yeah. Then
Okay.
transmit torque is again subset of that. So
10 percentage. So it's a generate rotation. It's rotate again. Again 10 percentage.
yeah.
And ensure reliability, durability, safety. It's all 5 percentage. It means 5. Yeah. Apply force, no need to pay any money because it's a lower function. Receive force 5 percentage.
All this 5 and 5, okay.
But apply force is no need to like apply force is out of scope.
Okay.
Maybe withstand load is very important. Maybe
Yeah, but
5.
here gears will apply force, right? One gear will apply force on the other, right?
Yeah. Yes.
Or for all these, we should give 3.
Yeah, we can put 3.
Reliability and all, and all.
Yeah.
Withstand load is again 3.
3.
Or maintain
3.
strength would be 5.
5. Yeah.
This would be withstand load again 2 or 3 is sufficient. Mid spec, what we have given mid spec 2.
Spec again 1, 3.
Okay.
3 is again you can put 5, 3. Okay.
And
Lastly, we have last one we have considered only 57 percentage. Now we are considering it as overall 100 percent.
yeah, 100%.
For maintenance under 2 percentage cost. Okay. For resisting corrosion again 2 percentage.
Yeah.
Resist withstand again 2.
Friction 2.
Withstand heat 2. Withstand hardness 5. Maybe some
Noise is
higher.
5 and hardness is 5. Okay.
Yeah.
Environment is again 3.
Yeah. So you add.
So 97.
Okay. So till 3 you can give.
Yeah.
For resisting friction, 1 extra we can give. Withstand heat we can give 1. And corrosion also we can give 1.
Okay.
And highest contributing 5 is there, no? Then 50. So here also 55. So top you see 30 plus 10 plus 10 plus 5.
5.
Even yeah. So here you give 6 to 1. You give maintenance strength. You use maintenance strength you want to give because already we have taken the maintenance strength there. So here we can give 6 to prevent noise or which prevent noise so that we can get more ideas.
6. Okay.
Yeah.
Hardness we can give, I think 3 or 4 is okay.
Yeah.
Then strength I can give more 6, 7.
In housing, how many? Yeah, how much you got in housing?
Okay. Now it is coming to 99. So one more.
Okay. No, in housing, we given more to what? Like strength is there, no?
What we'll do in housing also, we'll do like this only. We'll say 57% is 100.
Maybe again you have to you have to modify it again.
Yeah. So we'll do it quickly in 2 minutes.
Yeah.
Because now then it will be uniform. Otherwise now I will later on I will get so confused.
Yes. Then again you can create one more column also. Then you can multiply accordingly.
One more column
for the 57 percentage and 30% like that. That you can do it later on.
Okay. So here if I say
no, you let it be like this only. You create one more column. Give me control. I will just tell you.
One second. Okay. So 1 second. Where is that? It says stop share. Oh, sorry. 1 second. I'll say share.
I will take the control.
How do I give the control?
No, I will give request. Okay. I have requested you.
Okay. Yeah.
So here what you have to do, let it be same thing. Let it be same. So here you can create one extra column.
Okay.
So what you have to do is that you copy this and you can paste here.
Okay.
Now 30 into this, you have to give the value. So here this will give you the this is the percentage resource. This is the you can put here you can give a comment. You can mention this 100%. Like you can hide this one after calculating this. You can hide this one. So first, like we can calculate for 100%. Then what you can do is that then we can calculate. We can multiply this 100 into this value. Then we can put it here. Then finally we can hide this one.
Okay. So for this, for the housing, maintain spec. So 157 is 100. So again, protect the basic function would be 30% here.
Basic function is
Or
30%.
Or it should be 35.
Yes, you can put 35. You can put.
Okay.
Then you need to discuss again. Like we are giving randomly, but again,
Yeah.
Something we have to look into it. Yes.
I think you have the control. Yeah.
I have to give you control.
Okay, you gave me the control?
Yeah.
Okay. So here I'll put 35, right? Then withstand vibration is again 5%, right? Or 10.
Yeah, for vibration can put 10. Yeah.
Even strength would be 10 because strength is a very important factor. Then meet spec. Again 3. Standards 2. Or all these reliability, durability again 3. Connect components would be 5. Withstand load would be 5. Prevent leakage would be again 2. Corrosion is important, so 3. Integrity is important, 4. This should constitute to 100, right? It is coming 88.
Yeah.
88.
Yeah.
Appearance is again 2. Brand is again 1. Force receive force 2. Environment. So 95.
Yeah, remaining 5.
Reliability, strength. Durability 4. 97.
So we can multiply this 35% into 57%. Accordingly, you can give the.
Yeah. So okay, now this is done. Okay.
So what you have to do is that you put here equal
Equal
3 into 0.5 means 0.57. Correct?
multiply
Into 0.57.
0.57.
Yeah. And you drag it for the complete value.
Okay.
So coming 57. You just check it whether it is coming 57.
Yeah, it's 57.
Yeah. So same thing, you have to drag it. So 30 into 30. You put equal to.
1 second. If 19. Sorry, this would be into 0.30. 9. 30. Yeah.
Yeah, this is also coming 30. Yeah. 10.7. Maybe we not got 100%.
Yeah, that is rounding up.
So similarly, we'll go with the shaft.
Okay. So again here transmit power is the basic function of the shaft. So I think we can do it.
Yeah, it's almost same like
Yeah.
gears, but again in shaft, the extra you need to understand what is the extra thing.
Yeah. 1 second. I'll just do one thing. For time being, I'll just copy this. Let me do that. This should be how much? 100. I do this. 5 rotation. 5 So this is becoming 65. So this should be 100, right?
Yeah.
So important. So if I do this as 25 torque, if I give 8, if I give 8, Strength, if I give 10, strength is important. T3, strength is important. Rotation is there. Corrosion is important here. Sheep is hardness, strength. Shaft breakages are generally big issues, so I think safety or durability should be more, right?
Yeah.
So 86. Apply force, receive force, withstand load. Heat is also important here. Withstand load. So if I give 5, 18,
So here you can do some brainstorming.
yeah.
Since you are in purchase, you know like how much they are spending money also.
Still more than purchase, I'm still biased towards designing.
Okay.
Since that is my
Okay.
core area.
Okay. Oh, you moved from design to this one.
Then my role is the same.
Okay. Okay.
From design, I had moved to value engineering.
Okay.
But
Then again.
value engineering was a separate branch.
Okay.
Now it got attached with purchase.
Okay. So you have experience in design, value engineering, and also purchase.
Now I'm getting in purchase. Load I will give here 8 because load is important factor. Load I will give 10. This durability is 7. Then shafts are susceptible to all this. Safety is there for. Okay. Okay, done. So this is this into 0.1. Okay, done.
So this is for complete value is coming
13. Pardon? What did you say?
13% overall. It is coming,
Yeah, it is coming.
and last one for gears.
For gears also it is there. Correct. So if I say it is coming 30%.
Okay. Then okay. Okay. So now we can hide the thing.
Okay.
You can hide that one. Yeah.
Okay.
So now, yeah.
So just 1 second.
Yeah.
Here is first 5.7, 5.7. So I'll just mark the main ones
Yeah.
just for my understanding. Here 9 is main. Then this important. Okay.
Top three contributing. You can mark for top three.
Yeah.
Yeah.
3.25, 1.3, 1.3, 1.3. Okay. Yeah. Okay. Yeah.
Okay, so the top three again. Down also third one. The shaft also you need top three.
Here for shaft, 4 are there. Or should I choose only 3?
Okay, it's okay. Then it's okay. Fine. This so good. First, okay, same. It's okay. Leave it. Now what we can do? We will go for a fast diagram.
Okay. So what I'll do here itself, I'll put one more here.
No, fast diagram we can create in the same sheet.
Same sheet.
And then we can copy paste and.
Okay. Okay. Okay.
Or you can create. Go to the sheet to.
Copy that sheet.
Copy that sheet and put it in.
Okay.
Yeah. Sheet 3. You put change the name as fast.
Yeah.
Okay. So you can create a fast right side of this. Yeah. Let it be that. Okay.
Is text?
Let it be like for your understanding good.
Okay. Okay.
Or anyway, you have that one. Leave it.
Yeah. On the previous slide, I had that.
Yeah, you delete.
Because that this will the fast diagram, if it becomes bigger, then we'll have to.
You delete.
We'll have to delete that. Okay.
And sheet number 2, you can put as random function. Rename it as random function. Function. The sheet number 1 is the resource allocation for the cost detail. You can just put cost details, cost detail. Okay. Now we can go to first diagram.
Yeah. So here I'll create the lines.
Lines is not good. Like we can start with the basic function.
Okay. So
now what you have to do is that the basic function of a complete transmission is to transmit torque.
Right.
So here the basic function remains, it changes. Transmit torque. You put transmit torque and you fill the color with yellow.
Pardon?
You fill the color with yellow.
Okay, this one.
Yeah.
Okay. So this becomes the basic
function.
Okay.
Yeah, you can write, and we will follow the higher order function to lower order function in yellow color.
Okay.
And then now the higher order function y to transmit torque.
To transmit power.
Yeah, but for transmitting power, we are allocating the money.
Okay. So if your higher order function should not be the one putting money.
Yes, but here what we have to do is that instead of taking transmission, what we can do only for this 3 part alone we can take.
Okay.
So in this case, the basic function will be to transmit power.
Right.
Right. Yeah. So for this 3 alone, we can create the fast diagram.
Just 1 minute. I'll just mention here. Basic function considering these 3 items. Okay. Okay. Yeah. So then transmit power. Why will I transmit power? Because I want to.
No. Yes, we need to perform like the vehicle performance, meet performance, or
meet performance. Yeah.
Or enhanced performance. Like
enhance or meet.
Enhance will be good, still better. Enhanced performance.
Okay.
Vehicle performance. Enhanced performance will be good, right? And how to transmit power by transmitting torque?
How will we transmit power? Correct, by
Transmitting torque.
trans
Transmit torque.
transmit torque.
How to transmit torque by generate rotation?
Transmit torque, then
Rotation, generate rotation is there.
it will generate rotation, correct. How will we generate rotation?
By receiving force. Receive force and apply force.
Correct,
So,
correct. Receive force.
Transfer force, like transfer force. No, you put transfer force.
But first we'll receive, right?
First, how to generate rotation by transfer force? How to transfer force to receive force?
Receive force.
Then apply force.
How to receive force? By
apply force.
Force.
Okay, this apply force and enhance performance. Yeah, both you put it in green. Green, you highlight this apply force and enhance performance in green.
Okay.
So here, one thing you need to look is when you're writing verb and noun combination, you put capital letter E. Enhance performance P should be capital. Transmit power should be, everything should be capital.
Okay. Okay.
That is the thing that normally you can.
Okay.
Even when you're doing for a random analysis also you can.
Yeah, I'll do that. Yeah. Okay.
What we can do here is now whatever the resource transmit power, you have put 9 plus you can, okay, first we'll complete the fast diagram, then we can allocate the resource.
Yeah.
Okay. Next will be the all time function, one time.
But is this only the this critical path?
Yeah.
Will it not be more like here there are so many functions over here?
And that we need to put it in project objective or one time function, all time function. So we need to put all these things like that.
Okay. So here we will have objective, right? Here.
Yeah, project objective, one time function, all time function.
Objectives. Okay.
Yeah, project objectives.
Objectives. Okay. Yeah. So project objectives here will be we'll have to select from all, right? From housing, from this thing.
Yeah, and again, this project objective, again, you need to have the discussion with your team members.
Correct.
As function team, which one will be a part of project objective, because this will vary from case to case.
Correct, and it will have some specifications also.
Yeah. So, but meet standards, meet specification, everything will be a part of project objectives. You can put meet standard, meet specification, maintain strength, withstand temperature, vibration. All this will be a part of.
One second.
Prevent leakage is also a part of project objective.
So leakage, then what did you say? Leakage. Then,
maintain strength.
Strength, durability.
Yeah, ensure durability, reliability.
Reliability. Then safety.
Safety, yes. Ensure safety is
Safety
also.
will be all-time function, right?
Ensure safety. Yeah, again, it is up to the team members to decide whether to put that in all-time function or you put it in project objective, no problem.
Okay. Then
Even enhance aesthetics. Aesthetics can be the all-time function.
Corrosion and all and all.
Corrosion should be whether it should be a project ability or this one. See, enhance appearance can be the all-time function.
Enhance
Appearance, connect components, identify the brand. All this can be the all-time function.
Connect components.
And even protect.
These will be all time, right?
Yeah. What?
Appearance, connect components will be all time, right?
Yeah.
Okay. Appearance, then connect components, then
identify brand.
Brand, okay. Brand. Then,
and in case even sometimes you can put ensure reliability. You can put the ensure reliability even in all-time function.
Okay. Ensure reliability.
And you can put maintain integrity in the case of project ability.
Yeah.
And even ensure safety can also be either you can put it in project ability instead of
Safety. Okay.
And then resist environment you can put it in project ability. And this it should also protect component. So protect it can be the all-time protect component can be it should also protect component. So it should be a project ability, right?
Okay. Yeah.
Prevent leakage should also be a project ability. And then what you have to do is that in all-time function you can put prevent corrosion can be all-time function. Resist corrosion can be all-time function.
Okay.
And then if you put support weight something like that, no, we do not put support weight. Or even withstand distribute load or withstand load can be all-time function. It depends again.
Heat and friction. Right? Heat and friction, right?
Yeah, resist corrosion, no, friction.
Yeah, corrosion, heat, friction, all that all time.
Okay, all time you can put. Yeah, withstand load, even withstand load also can be all time function. Withstand load.
Load, okay.
Even enhance appearance, you can put it in all time function.
Yeah.
Prevent leakage should be the project objective. And withstand temperature, pressure should also be a project objective. So here the warranty is also very important. It should be the one-time function, right? So you can put only one in the case of all-time. Even protect product should be one-time function. Protect product. Instead of all-time function, you can put it in one-time also.
Protect
product.
But it will be all time, no? Or it should be one time?
No, again, you need to decide, right? So, but anyway, you are going to allocate that particular resource.
Yeah, yeah.
You can put either in one time or all time. Doesn't matter.
Okay. Then what will come in one time?
Ensure warranty, because warranty is also very important. So, standards, prevent leakage and durability. Enhance appearance is
Project.
So if in case we missed out withstand load is all-time function. Okay. And heat. So whether we cover almost all, ensure durability, reliability can be all-time function.
Durability, strength, that I have put as a project objective.
Okay. At least the reliability you can put it in all-time.
Yeah, reliability is all-time. Yeah.
Okay. So here it is up to the team members. Like you can decide which one should be accordingly. You can. So again, you consider noise also, no? So withstand noise. So noise should be the project objective. guess it should be
withstand noise.
Yeah.
That is project objective.
Yeah. So now we need to see whether we have almost covered all the things or not. Then now what we have to do is that we need to add, say for example, transmit power is there, right? We need to add
Transmit power. Yeah.
You go to the random function, so you need to see how many resource, how much. So 9 points is given for transmit power for here, and down come to shaft. Come to shaft. Shaft is given 3.25. So 9 plus 3.25 is 12.25, right?
9
for transmit.
So this one, right?
Yeah. So you do 12.25 there. You put 12.25.
Where?
Go to the fast diagram.
So this 9, this 3.25, and this 19, right?
Yeah. No, not 19. You give me control. I will just explain.
1 second. Yeah, you can take control.
So here I am going to allocate the resource here. So for transmit power, 9% here, and then 3.25 here. So 12.25. So what you have to put is here is you have to here put 12.25. Is the percentage allocation. So for similarly for transmitting torque 3 plus 1.3, 4.3. So from this you can also see, and for generate rotation how much you are going to spend 3 and again same 3 and 0.65. So 3.65. For transferring force, you need to see how much is the transfer force. So if your transfer force is there, nothing here, no?
I think it is in transfer force, like no. Or we can say this apply, receive, all that, no?
That's why you need to transfer. Transfer force not considered, no?
No.
Okay, so instead of that, we can take apply force. Okay, it's a lower order function, but still we allocate resource for that 0.39 plus same apply force here 0.39, 0.48 we can put. For it, and for receiving force 0.9 plus
0.39.
0.48.
0.48.
So we need to go to the project objective. So meet specification. You see here, I need to add all the things. So here for all the 3 things I need to add. Meet specification how much. First one is how much I want.
On top 1.71.
Okay, 1.71 plus
plus 0.9.
Okay, 1.7 plus 1.79, then down.
Down spec, no? 0.39.
Correct?
39.
Okay, 1.79 plus 0.9 or 1.88, 2.1, 2.18, 2.18, right? 0.18, 0.19, I think. Put approximately 2.18. Correct only, no? 1.7 plus
1.7.
So now what you have to do is that you have to individually put what is the resource here, percentage here
Okay.
for all. Now this we can see the top 3 or top 5 contributing thing. Then we can go for idea generation. Maybe I will give you control. You put the values so it will be
Okay.
easy.
Yeah, yeah. Meet standards. Okay, meet standards. Standards is 1.7. What I'll do, equal to this plus standard plus this plus standard this. Okay, like this I will do. It will be easy. Leakage this plus strength is equal to this plus this plus this. Durability is equal to this plus this plus this. Integrity equal equal to integrity this plus 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 and then this is equal to this plus this plus this. This is equal to this plus this. This is equal this is equal to appearance from connect components.
You're done now?
Yeah, done. But for one time it is not there.
Protect product.
Protect.
So protect component and protect product are same, no? So what you have to do is that you put that protect component and protect product both are same only.
Okay.
No, it is like you put that as a one-time function. Yeah, you can convert like that also. Yes, that will be still better. What you can do is that you can change it. This protect product and protect components 19.95 you can put. Anyway, that will be the highest cost contributing factor.
So I'll
You know,
change.
it can be the project objective because since it is coming at a higher cost, so let it be in this one. Yeah, this
Okay.
protect product is like overall.
Budget objective.
Yeah, yeah. Instead only instead wanted let it be.
Okay, then I will do this protect this thing as this thing.
Protect component is 19. It's already we put no protect component 19.95.
Yeah, already there.
Yeah, you delete it.
Okay.
So here now you put the highest cost contributing in red. So the highest is 19.95 is first one. Put.
Okay, this is red. Okay.
And the next is transmit power 12.25. Third one is
4.3.
huh?
4.3.
4.3 is highest. 4.66 also there.
8.8 is there.
Yes, then yeah. Then you go for top five. Top five you can go.
Okay.
Then durability.
Where is it?
Withstand.
Load. Okay.
Okay.
So this is one.
Cool. And five is transmit torque. Okay. Durability. Withstand durability.
Yeah. Okay.
You go for six. Transmit torque also. 7. You go for generate rotation 7.
Okay.
Even 10 also good. Like but we need to collect ideas like that.
Okay. Then connect components is also there. No?
3.42. Yes. 7,
Okay.
8.
That
Yeah.
is
Put that.
one
Yeah.
minute.
On it.
Corrosion.
Remaining 2. Additionally 2 you can put. Corrosion 2. Corrosion. And 3.26. And safety.
Okay. Okay.
So here we consider 10, but it's good that even if we consider top 3 is also good.
So these are like top contributors, right?
Yeah. But the thing is that we need to select whether you're going for. I personally suggest you go with the top 3. It will be still easy for you.
Okay.
And
Okay.
if you find time, because if you're taking all the things into account,
Uh-huh.
then while implementing it will take time also.
Okay. Then what I'll do? I'll take.
Top 3.
I'll remove this. Yeah.
Or still we can do some transmit torque, transmit power, and then protect component. So again, that's why here nothing right or nothing wrong here.
Correct.
So it is up to the team because you know the implementation time, durability for test because you need to do a lot of drawing, design, DVP. So you need to understand if you are taking more ideas or more functions, then it will take more time also for implementation.
Okay. So
So
these are top 4 now. What I've selected.
yes,
Okay.
withstand load, yeah, withstand load, maintenance strength. Yeah, top 5 you can take. One more thing you can take is maybe a transmit torque or so again it is up to this one like
So this I'll take transmit torque.
yeah, you can take transmit torque on this.
Yeah. Okay.
So next what you can do is that you can create one more Excel sheet which you can put ideas. You can name that as idea generation.
Okay, 1 second. Huh? I'll just quickly do this so that like this, right?
Still you can refine in the fast diagram using the material given to you, the book and all. You can use the PDF file.
Okay.
You can refine it.
Okay. So next sheet will be what? Idea
No,
generation.
all time function should be inside. All time function should be inside.
I'll put it inside. I'll do it later on.
Yeah. Next is that idea generation, creativity phase.
Okay. So what we'll do, I'll copy these these on that side, right?
Yes. No. Next is you put not creativity phase. You put one more function cost worksheet. You see the function cost worksheet. You put. Function cost you put.
Okay. FCW, right?
Function cost. Function cost for no. You can do either two way. I will give you one easy method. Okay. You put function cost.
Okay.
Okay. So here give me control. I will do.
Okay. Yeah, given.
Here, see what you have to do. Here you identify the thing, but the real top three functions you can identify only in function cost. Okay. So see, now I'm telling you how. Like initially, you might be wondering, you can directly get an idea by looking at this. Then you will get an idea by looking at the top. But the real top three you can identify in this function cost. Okay, how I will tell you. So you have three product. What you have to do is you have to list down like first one is the gears, housing. Next one is gear. Next one is the shaft. Okay. So here you need to put the price. What is the price of individual price you have to put. So here what you have to write is you have to list down all the functions. Maybe you can list down the top 10 or all the functions you can list down here. Okay. Then what you have to do is that for this housing, overall cost of 57 percentage. You need to allocate the percentage to the individual function. Similarly, the gears to the individual functions, up to the individual functions. Then you have to add vertically how much percentage or cost is coming. Then with that you need to find which function is contributing to the more cost. So here it may be higher, but the real thing you will come to know here only whether you need to allocate the what you can do now. You can create the function here. Okay, you can write the functions here.
Okay.
And then against that functions you need to give you have to give the allocation accordingly. So 100% of the cost for housing, how much percentage goes to the power? That is what we have done here. Similarly, we have to do here also. So still we can narrow down, and we can also ensure that whatever we allocated is somewhat okay.
Okay, so shall I do that?
Yeah.
Okay, just give me the control. Given?
Yeah.
Hello?
Yes.
You gave me the control?
I given.
Okay, okay. Okay, so what I'll do, housing is, here I will put 57%, right?
No, you put a cost you put as a cost rather than a percentage. You put as a cost 3213. Put a cost value.
3213, okay. All this I will do this is equal to 3213, okay.
And put 100%. You put 100%. Consider this 3213 as 100%.
Okay.
And similarly, the other value for gears and shaft, you put 100%.
100%.
Yeah.
Okay.
Similarly for gears and shaft.
1714 and 727. 1714. Okay. Okay. So, and here should I put all the functions?
Yeah, whatever it is in scope. Left scope to right line scope. You put all the functions.
Repeat again.
You put all the functions between the scope lines from left to right.
Okay, between the scope lines. Okay, so all these ones.
Yes.
Okay. Okay.
No, not only this four, but also the project objective. That also all these things you have to put. Project objective and one-time function. You put all the things.
Okay. 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 How to do this? I have to transpose, right? How do you transpose this?
Pardon?
How do you transpose this, all this into vertical, horizontal? Transpose, there is something transpose, right?
Yeah. You go to this format now.
Acha, format, okay. Format.
And no, you have to you put you type equal to transpose
Here,
and
here, equal to,
transpose and type that value.
okay, transpose equal to transpose. Pose, and
See, first what you have to do, you have to copy the data, means vertical thing, whatever then you copy it. Then find the cell you want to insert the data, and then click on it, select the paste button, but click on the down arrow.
just slowly, 1 second. I select all this, right?
1 second. Yeah, select it. Okay, and go to the I2. You put how many is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You put I2, I2R, I2R. You select I2R.
Okay.
No, always give me control. I will try.
Yeah, take.
To copy this.
Oh, okay. We have to copy and then put it. Okay.
And I2R.
Okay.
Transpose.
Okay. 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 Give me the control. Yeah. So this here. What I'll do, wrap this to that, and then extend noise, and then I'll come back to the past. Okay. Copy. Standards. Okay, so yeah, so this we have listed down.
So here, what you have to do is that again you have to allocate. So, so this is the correct procedure. So we need to allocate 100%. What is 100% for the housing? Individual functions you need to list here. So sometimes in the first diagram you will get to understand the unwanted function, but in the random function there might be the additional functions. But here you might get the correct functions which includes the expected functions. You can also avoid unwanted functions. So here again you have to look for 100%. So you need to allocate accordingly. So how much you are going to allocate?
So,
so maybe you can take this reference from the random function also, or what you can do is that you can once again look into it.
so here I have to fill just the percentage.
No, you see here for this housing, you have to fill horizontally all the functions.
Okay, all of these I should give.
Yeah, you have to allocate 100% accordingly for this 100%.
Okay.
And you have to multiply that percentage into cost. You have to multiply that percentage into cost for housing and the gears and shaft, and then finally you have to add all the cost for the individual function. Then
Okay.
you can understand.
Can you help me now? Can you for
Yeah,
transmitting power?
yeah.
So transmitting power is the no, it is for housing. The basic is
No, you unhide. We went for hiding and unhide, no? Something we hide it, no? In random function. Then this will help actually.
Okay. So protect components is having more value.
How much? 10% or 35%?
35.
Okay, you put you put 30.
For 1 second. For
Because here you need to put all the things, no? So you need to allocate the resource accordingly.
so here I will put 30, right? 35 or 30.
30. 30. Then finally we can modify, no problem.
Okay, okay. 30.
Similarly, you have to put for the housing, you have to give the values. Sometimes the friction, see, sometimes you will not get the friction here. So the friction will be 0 and identify brand very less value. You allocate yourself. I will not involve for this because it's up to you. Um, up to you means like you know like
Okay, so transmit power is not a function of housing actually. So
yes. So you don't need to allocate money for that. You put a 0. You put 0.
okay.
Transmit torque also 0. Yeah.
Also 0. Generate rotation also 0. Transfer force, it will not transfer, it will receive actually.
Mm-hmm.
So here also 0. Receive force, okay.
Mm-hmm.
So receive force percentage I have to give, right? So here I would give receive force is again 20.
Okay, but almost you consider something relevant like you can value you have to consider. Like what do you consider in random function?
Uh-huh.
Considering that you can also take that also as a reference. Because here nothing right or nothing wrong, but closely we are matching the value is very important.
Okay, so 1 second. This is receive force. So here we don't have receive force. We have receive force we have. So we have given 2. Okay. So if I give here 2, that is also okay. Yeah.
Yeah, that's it. It is up to you actually because here normally because when you're ignoring any consultants or any trainers, no, like they do not know because it is your own product and you know better than them.
Okay.
So that's why like,
Okay.
I'm not involved here. That's why.
Receive force I'll give a bit. Then even mix
This,
I will give. Then
this is 100%. It is not that. So for this 100%, you allocate accordingly.
yeah. So out of 100, 3% I would give to mid spec, right?
Yeah, yeah.
It means that, no?
Yeah, yeah, sure, yeah.
Okay. Then mid standard also, if I give 3. Leakage I would give 3. Strength I would give 10.
Same thing, even you can refer to a random function of how much you given, you can give the same value also, and you can modify accordingly. Even that is also okay. You copy that and you copy the values.
Okay.
Yeah, you copy the value.
1 second. Uh,
Yeah, better what you can do, you copy all the things. You copy and then paste it. No, it is not like it. Completely, including the verb and noun also.
including
The functions.
this.
Yeah, completely copy paste so it will be easy for you to you put directly.
Okay. Okay.
Otherwise,
Just
give me control, I will do it firstly.
okay. Yeah. You can.
So, so accordingly, you can give the values.
Okay. Okay.
So for durability, maintain durability, we are given 5.
Yeah.
2, 5, integrity. There is no maintain integrity, no? Maintain integrity 4.
Maintain integrity 4. Yeah.
Maybe we can give the same 35 also here.
Yeah. Environment is
Vibration and load.
Vibration is 10.
Okay, noise.
Noise is not there. 0. Appearance, 1 second, let me double check.
See, I think the same value will come here because what we have got here, we got the value here, right?
Correct.
What I feel, even if we do like this separately, we need to do similarly for gears also. Okay. Similarly for shaft also.
I'll copy those here.
And one second, what you have to do is that then we need to add, we need to multiply. See, this value into 3, you have to put the cost here. So this value into 3, you have to put the value here. So 10 into this much, the percentage of this value. So you need to put the value here, cost value. Then what you have to do is that you have to add the cost from like this. You have to add a cost. Then what you will get is that you will get the cost of the individual function. You will get, so here we have allocated the percentage in terms of percentage we allocated, but here you will get the overall cost for the individual functions. Then we have to select the top 3 or top 5. Against that, we have to create the ideas for the individual functions.
Okay. Okay. So what I'll copy paste them immediately.
Yeah.
Okay. Just give me the content. No. Yes. Components. Standards. Hello. Hello, Arjun.
Yes.
Yeah. So I have put all these.
Okay. So good. Now what we have to do now?
Uh-huh.
Now give me control.
Yeah.
See, basically now it is with respect to cost, not only the percentage. So this value into this value. So here it will be 0. So here it is 3% into 0.03. So what you have to do is that equal to 3213
into 3 by 100.
into
G 14 by 100.
to 0.03.
Will this give correct or?
Oh no. It won't be correct.
No. Just do undo.
So what you have to do?
I got it. Yeah. Okay. Give me the controller. So in function cost, what we do is we now allocate the cost to each function.
Yeah.
Right?
Yeah.
And we find out which is the highest cost contributor. Correct? Hello?
Yes.
So in function cost, we identify or we calculate the cost based on function, and
Exactly.
then we find out which is the highest cost contributors.
Exactly. Yes.
Okay. I'll just do it. Okay.
Yeah.
Instead of this, now what I'll do, G, or we can do it like this. This multiplied by bracket this divided by 100, and then we copy that to multiplied by yes, Arjun, calculate it. Hello. Hello, Arjun.
Yes, now what you have to do is that you have to add the functions vertically 0 plus 30 plus 25, 55 you have to put.
Acha, this we have to put, right? This.
Yeah, you put both resource percentage as well as cost, both you put.
Acha, okay, resource also and cost also, right?
Yeah, but better to go to cost only, but again, we will do it in a very systematic manner.
Okay.
Source cost, yeah.
Resources and
Resource in terms of percentage, cost in
okay, so this is equal to
So should be 55.
Plus this plus this. Sorry. Equal to this plus okay. Plus this plus this. 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 Yeah.
So now
all the resources.
you need to identify the highest, highest percentage value. Like
okay, so
if highest percentage and both will be same only. Like 55, you put 55 and 695 in red. You highlight it in green or you put it in green.
Green, okay. This and this side green. Then 695. This is one more.
Yeah.
This I put it in green.
But how it is coming like this? 80, it is coming 90. No, it will not be like this.
Pardon?
One second. It is contributing something different actually. 1 second. 30%. Okay. Okay, sorry. So here it is like this. So 30% into, or what you can do now? Since we have taken data science, okay, 100% will be good actually. Here resource percentage is not required. If at all, if you want to consider resource, what you have to do now? We have to consider this here. Give me the see. Instead of 100%, you have to put 57, 13, and whatever it is. So here you cannot take the resource because the percentage will be high. So 55 plus 35 itself coming 90. So it is not a correct method. So here the method is you have to consider the cost.
Only
Okay?
cost. We have to consider only the cost.
Yeah.
Okay, so I'll remove it.
See. No. It is like, can you give me the control? I will just explain.
Yeah.
What we have considered with respect to cost is absolutely correct. Okay, but with respect to the resource percentage, why I have considered 100 is it is easy for the initial level of calculation. So that's why I put 100%. Okay. But it is necessary to put 57 and then 30 and then 13. So same value only you have to put here. Since it will be difficult for to carry out the things, so I put 100%. So again, if it is 100 to 3, again you have to convert this one. You understand, right? Basically, we need to do like that only. But
Okay, I'm getting confused here now.
Okay, so
Should we cancel this whole exercise and do again?
no, it's okay. It's correct only. Cost is okay. Cost is okay. Do one thing, one second, wait.
Because there are so many functions and so many things now. It is becoming.
No, I will do one thing. See, yeah, it's coming 3052.
Oh, I think somewhere there might be typing error in the resource.
Okay, so nothing to worry. One second, I will tell you a very simple method. Okay, we made what we made mistake in the sense it's also correct method. So we have taken this value, right?
Correct.
But we need basically we need to take this value.
Okay. Okay, then what I'll do, I'll quickly copy that values.
It will be double work for you, know.
No problem, but I should get the correct one because I am getting myself puzzled here.
Okay. Yeah, no problem. Yeah.
Because there are
And
so many
again,
things, na?
see, why I have given 100%. You know, it will be easy for you to understand. That's why I given 100%. But it is basically you need to put the correct 57. That you put the same value. Okay.
Okay. So just give me the control. I'll copy it from the random functions. The percentage resource.
But the cost is coming correct, right? But cost is coming correct, right?
Yeah, because basically.
See, we do one thing. First, we will take the
To
cost.
take 57%.
No. First, we will take the cost first. 95 plus this much. Then what is the next value? Next contributing is highest contributing. First one is rotate component is higher, okay, and the next one is transmit power, okay, and then the third one.
What K.
Okay.
Yeah.
Okay. 3.
Then.
Okay. See, we will add the 3 value. 695 equal to this plus this plus this. So 2, 3. So when we add all these 3, it is coming as how much is the value of these 3? Okay.
5654.
5654, no? 5654. Okay. And then still we can add one more. The fourth, 4 or 5, fourth one. Which one is the fourth?
There is one L.
L? Okay, this is the 4. Okay. 5?
Can you take to the right side? 316.
Huh?
Last one.
See here. So now when you add 316.9 plus so equal to this plus
6234.
6234.
Yeah.
623.4, no?
Total. That 5654 what you wrote now, that is 6234. Below that you wrote 5654.
This 6234.
34.
Oh, after summation of all three. No, this plus this.
Okay. That is 5654. Yeah.
Yeah. So and then here we need to add 1 plus this 2. We added, then this is equal to this. Plus 262. So top 5 contributing is this much. So when you divide this 2 8 along with this one, almost 50%. Okay. So what you can do, you can contribute, you can take with respect to cost, you can take the highest thing. Okay. Then you can also see the transmit power is the first one, or say protect component. Okay, we got even in last one also we got the same thing, right?
Right.
So first idea, we have to collect the idea with respect to this function. Next one is the transmit power. That is what we got here also in fast diagram also.
Yeah.
Transmit power, and the next one is the third one is maintenance strength, right? Maintenance strength, no?
Protect component.
Third one is maintenance strength actually. So third one is maintenance strength. Okay, same thing here. We are getting same thing. Okay.
Yeah.
And the next one is withstand load and durability. So here withstand load and durability. Same thing you can get it here. Withstand load, and then durability. Yeah, durability is also 4.6. Okay. Correct now.
Yeah.
So here everything is correct. Only thing is that what we have to do is that here we need to consider the value accordingly. So what we have considered with respect to cost is absolutely correct. Okay. And here what we need to do is that we need to do the sourcing allocation, not for here we need to do some correction. So here it is 57%. So
Yeah,
accordingly,
just do one thing. Instead
yeah.
of that 100, now just write there 57%.
Yeah, you now like you yourself can do it, no? 57.
Okay.
That is, yeah,
I'll
this,
do that.
yeah. And you can multiply 57 into 0.3.
Okay. One second. So this is 57, 30.
But cost wise it's correct. Cost wise it's correct. No.
7, 30, 30. Yeah. So and here I will put transmit okay. Generate the rotation transfer. Receive force. So This I have to put 1.14. 1.14. Correct, no? 1.14 I have to put here. Gears. Go to gears and copy resource function, resource percentage. Copy resource percentage. Constant calories. Nine. Transfer force. Nine. 2 is standard. Standard. 0.6. Leakage is in what and strength. Strength is 1.8. Then that could be for the shaft. Shaft. So transmit power is 25. This is 3. Then 1.3. Then you have 5.6. 6. This is 0.3. 0.39.
I think the same value what we got in first diagram, right?
Yeah, just 1 second. 1 second. Just completing that only. 0.26 meet standards. 0.26. Yeah, 15. Then for 10 it is 1.10 is what strength. 1.3. 7 is 0.1. 4 is 0.40. 4 is 0.5. 12 is 1.3. And 5 is 0.65. Yeah, so if you see the highest cost contributor is again 177, 233, 113, 640, then 134. Yeah, again the same ones. Hello.
Yes, I understood. Yeah. Now
Yeah.
what you
again the same ones. Yeah.
Yeah. So now we have to go for a creativity phase. Or I will give you one more idea. Like even in this function call, see here, I'm taking the control. So
Yeah.
here for the individual function, this is the function cost. Okay. For this transmit power, I am spending I'm spending this much money. So what will be the worth? So again, this is again subjective.
Okay.
Okay. If you are very much well aware of the worth, okay, then you can put the worth here. So function cost minus function worth will give you the value gap. Higher the value gap, you can look for the.
If you want to give worth, how will you define as an example?
See, that's what I given one example of the example of a lighter. Lighter, you can do it as a matchstick. Okay, what is the cost of a lighter? What is the cost of a matchstick? What is the cost of a
So the
10?
lowest, it says that it is the lowest cost at which the basic function can be achieved.
Exactly. Any function. It's not only the basic function. Any function. So
Okay.
here,
So now
here,
your function is transmit power. So
yeah,
what is the lowest cost at which transmit power transmission can be done, right?
exactly, yes.
Okay. Okay.
But you need to do a lot of practice for that.
Yeah.
But now this is the best method for you. So
But
still,
this is worth is subjective, right?
yeah, again, this is subjective, yes.
Because the whole team will sit together and then define it, right?
Exactly.
So here, but but this will again be arbitrary, right? So
Exactly.
you will feel 20, I will feel 30, someone else will feel 40. So how do they like converge on a value?
So it is like, see, it is like how we are giving the value here, the percentage. Okay.
Mhm.
So similarly, the worth here, what you need to give, it is based on the should cost and also based on the benchmark. So you will have some benchmark. For that, you need to use some sourcing and you have some software also for that.
Okay, some assumptions, some previous data,
Yeah, something
some previous knowledge, or
exactly,
some
exactly.
benchmark data. Okay.
Yes,
Okay.
yeah,
So all that will contribute, and then we will get a better understanding of the work.
exactly, yes.
Okay.
So next we can go with the next phase called the creativity phase. Where here what you have to do is that you have to you have to create the ideas with the individual function for transmitting power. Keeping this function, we need to create many ideas how I can transmit power.
Okay.
Uh, so this you can take up with your cross-function team.
Mm-hmm.
Uh, Maybe you can take some. Maybe you can arrange one day also for your own team, like your company. What you can do, you speak with your cross-function and create the ideas.
Mm-hmm.
Uh, Maybe you can take all that in also. So and you can create ideas, and then after creating the ideas using brainstorming technique, then what you can do is that you can evaluate the ideas based on the two criteria I told. Like you yourself, the cross-functional team can give the rating based on paired comparison and evaluation criteria, and you can decide that based on ranking and you can select the best ideas. Then you can present to the top. You can develop that ideas for your using drawings, 3D, CAE, CFD, whatever is required. So here the ideas have to start. You have to start the ideas
Okay.
from the functions, whatever you got. So here you use your cross functionality to
Okay.
develop the ideas. So
Okay.
how, like say for example, how I can transmit power. So using gears, shaft. So what can the gears can be made up of plastic
Right.
uh, instead of metals. You can give that as an idea, or I can use something. Something you can use think of your own like how you can or you need here you need to have some brainstorming session. You need to collect more ideas without affecting the function. Then again you have to evaluate the ideas based on some criteria. It can be weight, or it can be the cost, or it can be the reliability, performance, or safety, or investment, manufacturing feasibility. So whatever the criteria you decide from by your cross function, then you give the rating one the rate of 1 to 10, and all the cross-functional team, maybe 6 people or 10 people, you individually rate the individual ideas and decide the best ideas. But here this function fast diagram, random function fast diagram function cost will help you to identify the highest cost contributing function, and also you will get the unwanted function or unnecessary cost can be reduced.
Okay.
You can take this